Hello and welcome to the Scientific Adventures of Beardman. Well, we just finished learning how to turn relationships such as quadratic proportions or direct proportions or inverse proportions into an equation. Now we're going to kind of flip that around and look at, if we take an equation, can we see what relationships exist in it? Well, in order to do this, we're going to be using the California Physics Reference Sheet, okay, which you can see here. You should get a copy of this in class. You can, if you're not in my class and you happen to be looking at this, you can find it on the internet. Just type in California Standards Test Physics Reference Sheet and it should pop right up for you. But those are the equations that we're going to be using. So as we take a look at them, if we take a look at an equation like, let's just say we take the current equation, which is right here, okay? So you can look at your own. That equation is I equals Q over T, okay? And so we can look at that equation and there's several relationships we can see here. We can see there's going to be a relationship between I and Q. And keep in mind, for this point in the year, we're not talking about what Q is or what I stands for or what T stands for. But later on, we'll talk about the meaning of each of the equations. But for now, I want to be sure you understand what the equation is telling us. Okay, so first of all, if we look at the relationship between I and Q, we can see that they're both on opposite sides of the equation, and they're both in the numerator. Because keep in mind, if there's no fraction, that's like writing over 1. Okay, so the I is in the numerator and the Q is in the numerator. This shows us that if one side gets bigger, the other, or if the Q were to get bigger, that means that the I would have to get bigger. And if the Q doubled, the I would have to double. So this would be a directly proportional relationship. The next one, which is also fairly easy to see, if we look for the relationship between I and T, we can see that I is in the numerator on one side, T is in the denominator on the other side. And so we can see that if we were to make T bigger, divide by a bigger number, that means that I would get smaller. So if T gets smaller, I gets bigger, and the opposite would be true as well. If T gets smaller, we're dividing by a smaller number, and that would make I larger. Therefore, we can see that we've got an inversely proportional relationship. I is inversely proportional to T, or you could have written it the other way around. Now, the most difficult relationship to see for most students at this point is the relationship between Q and T. Okay? Because they're both on the same side of the equation, lots of people will instantly think, oh, numerator, denominator, they must be inversely proportional. But in order to see the relationship, it's going to be easiest for you to get them on opposite sides of the equation. Okay? There are ways to look at it like this, but let's, for our sake, let's do it this way. So if we take this, and to get them on opposite sides, the easiest thing is going to be to multiply both sides by T. Okay, so if I multiply both sides by T, the T's cancel, and I get T times I equals Q. Okay, and now I can see that if T were to get bigger, Q would clearly get bigger. They're both in the numerator when they're on opposite sides of the equation. And so we can see that T would be directly proportional to Q. Okay, so remember, when you're looking for the relationship of two things in an equation, to make sure you've got those on opposite sides of the equal signs. If not, do a little bit of algebra and get them on opposite sides of the equal signs. And then you'll be able to see that relationship, whether it's directly proportional, they're both in the numerator on opposite sides, or one is in the denominator and one is in the numerator. Okay, this is a situation we don't have on our particular sheet, but let's say we had A over B equals C over D. What if we wanted to know between B and D? Well, they're on opposite sides of the equation. They're both in the denominator. Well, if they're both in the denominator, that's like if one gets bigger, well, it's a little bit harder to see, but if one's getting bigger, that makes this whole side smaller. And if we want this whole side to get smaller, then D would have to get bigger. So those are both going to get bigger together and smaller together. Of course, you could shift them both up to the numerator if you wanted to see it that way. But if they're both in the denominator, then that's going to be directly proportional, as well as if they're both in the numerator. So A and C would be directly proportional, and B and D would be directly proportional. The last thing I want to look at today is to put some numbers to our situations. Okay? Before we actually start plugging in and getting answers, I want to take the equation and just kind of set up a situation. I changes from 4 to 8. If Q was 5 when I was 4, what will it be now? Okay, so we've set up our original values, you might say. I is 4 and Q is 5. Remember that we can recognize that I and Q are directly proportional. And so if I changes from 4 to 8, that means it's changing by a factor of multiplying by 2. Well, if they're directly proportional, if we multiply I by 2, then we're going to have to multiply Q times 2. Since Q was 5, that's going to lead us to an answer of 10. Q will now be 10. Now, if we did this with something that was inversely proportional, it might look like this. I changes from 4 to 8. If T, now we're doing something that's inversely proportional, I and T are inversely proportional. If T was 6, that's the original value back when I was 4, what will it be now? Well, once again, let's look at the factor, knowing that I and T are inversely proportional. Okay, so if I changes from 4 to 8, that's changing by a factor of multiplying by 2. Well, if we multiply I by 2, that means we're going to have to divide T by 2. So T divided by 2, which was our factor, is going to give us 6 divided by 2 is 3. Okay, so T will now be 3, now that I has changed to 8. Okay, now keep in mind that these things will only make these changes if we keep everything else constant. So in this situation, Q would have to be held constant. In our last situation, T would have had to been held constant. So remember, when we recognize these relationships between two things, that we recognize other things may impact it, but it's when we ignore or when we keep all those other things constant that we're able to see the direct or inverse proportionality. Thanks for joining in with us on Scientific Adventures of Beardman as we looked at recognizing relationships in equations. Stay tuned next time as we begin to look at plugging values into equations.